Welcome to the Crazy Hat Chemist. So another video, in fact, a whole entire new unit here on solubility. But before we get started, a little advertisement here. Okay, don't forget, if you go to my website, thecrazyhatchemist.com, you can donate to my website so I can keep on making videos. If you donate, you can get yourself a sticker. Super cool. Or if you donate a little bit more, you might even be able to get yourself a t-shirt. Look at that. Isn't that cool? And website on the back. Super cool. My son made the design for the whole thing. So, without further ado, let's get started on this solubility unit. So, bam! So today we are talking about the relationship of solubility and equilibrium. This is just a little bit of information and then a little bit of a review. So, precipitation reactions, i.e. the formation of a solid or the dissolving of solids, affects our lives in multiple different ways. Okay, here are just but a few examples of this. Number one, in the purification of water from a well, the selective precipitation of certain toxic metal ions can be accomplished to make water safe for consumption. So we can selectively precipitate out some of the toxic ions, so like lead ions. We don't want to be drinking lead or iron or certain other ions that are toxic to the human body. Okay? Number two, the dissolving of tooth enamel in acidic environments leads to tooth decay. So depending on what you are drinking, okay, for example, if you're drinking a lot of sodas and stuff like that, that leads to dissolving of your tooth enamel, and that of course is not good because there's a precipitation on your tooth essentially. Number three, in order to see the intestine of in order to see your intestine, a solid precipitate, that is barium sulfate, is used to diagnose ailments using the visualization of x-rays. So what you have to do is you drink this white chalky liquidy stuff that is actually a solid precipitate in that white chalky liquidy stuff, and then they take an x-ray of your stomach and they're able to see your intestine, okay, and your stomach and your large and your small intestine with this barium sulfate precipitate. Cool. Okay, it is radioactive also. Number four, the dissolving of marble, which is composed of calcite, which is a precipitate of calcium carbonate, and dolomite in acidic conditions, i.e. acid rain. So if you have a wonderful Michelangelo statue that he made and you have it outside and it starts raining acidic rain because of what we have been doing to our environment, that would be a bad thing because it's going to start dissolving that statue. Don't want to do that at your Italian villa for certain. You want to make sure that your marble statues are all inside in your Italian villa. All right. So here's a little bit of a review of the equilibrium constant. We've gone over this before in the equilibrium unit, but we're going to be using this frequently for this chapter, and there's a specific reason why we're using this here. So for any equilibrium chemical reaction, we have this equation right here. Okay, the lowercase letters are the balanced stoichiometric coefficients from the equation. The capital letters are the formulas. You should know that this is including states of matter here. We got solids, aqueous, gases, liquids. Okay. All right, so the equilibrium constant expression, the KEQ, is the products, or the product, divided by the reactant, or the reactants, using the balanced stoichiometric coefficients as exponents. Furthermore, solids and liquids, but specifically in this particular unit, solids are not incorporated into any KEQ expression because they do not affect the value of the KEQ itself. Okay, so we're going to write the equilibrium constant expression, that is the KEQ for that above one, just like what we've done before. It is products over reactants with the stoichiometric coefficients as exponents. You should see that the F on the product side is not included because it's a liquid, and for this particular unit, the A, which is a solid, is of course not included. Okay. The KEQ is temperature dependent, and we're going to be discussing that here in just a bit. When the KEQ is less than 1, that means that the system is reactant favored. When the KEQ is greater than 1, the system is product favored. And when the KEQ is equal to 1, the system is at equilibrium. Okay, so take note of all this information. This is just really more of a review than anything because you should already know this. I am the Crazy Hat Chemist, and of course we can't end a video without having a crazy hat. Check out the length of that hat. Whoa! Okay, if you like that video, give me a thumbs up and pass on my videos. Subscribe to my YouTube channel, please. I'll see you next time for more cool chemistry videos. Bye for now.